Alright, today we're going to start Unit 6. So this is Astronomy number 1. And your question of the day for today is, what is your definition of the term astronomy? So go ahead and fill that out in the first couple of blanks there. And we're going to go ahead and move on. So we're going to start with Chapter 22, Section 1, Early Astronomy. So there are some things that you need to know about how astronomy came to be what it is today. So what we're going to start with is the definition. So the actual definition of astronomy is that it's the science that studies the universe and everything that makes it up. Okay. What we have here on the left-hand side is an astrolabe. And this is actually what they used back in the day to track the position of the sun and the stars. So we're going to start out with the ancient Greeks. They are the originators of astronomy, and they actually came up with what is known as the geocentric model. And that's where they stated that the moon, the sun, and any other planets that they knew about, everything orbited Earth. So this is an Earth-centered model. Okay? So anything else is orbiting around the Earth. The Earth is the center. But what we know today is the heliocentric model. So Earth and everything else is orbiting the sun. So it is a sun-centered model. So really quickly in your notes, I want you to sketch a geocentric model and a heliocentric model of the universe. This does not have to be perfect. Just do your best with this. And I want you to write just a little caption below your sketches telling me the difference between the two. Okay? And you can either stop the video now or you can go ahead and let it play through and come back and do this at the end. But please don't forget this. I'm going to give you extra points for this when I take up your notes at the end of this unit. So geocentric versus heliocentric, this is kind of a general idea. So we have Earth-centered over here on the left-hand side. You can see the Earth here at the middle. And you have all of these components around it. And then on the right-hand side, you see the heliocentric. So we have the sun that's the center. And you have the Earth as well as a couple of other planets that are stationed around about. But let's keep talking. We have what's called the Ptolemaic system. The P is silent, so it's Ptolemaic. And that is a model of the universe that accounts for how the planets move. And what you see here in the image is an example of the Ptolemaic system. We also have retrograde motion, and it's an apparent westward motion of the planets with respect to the stars. So as we look into the sky, everything moves from east to the west. So for example, when you're looking at the sun, or if you're looking at Mars, from the Earth, everything seems to move right along with the stars. Okay. So retrograde motion, Earth has a faster orbital speed than Mars, and so it quickly overtakes Mars. So it moves more quickly than Mars does. So let's talk about the birth of astronomy, or modern astronomy, and what or who really came into play into making this. So the first guy we're going to talk about is Nicholas Copernicus. He decided that Earth is a planet, and he proposed the model of the solar system where the sun is the center. So he's our heliocentric guy. We also have Tycho Brahe. He designed and he built instruments that would measure the locations of these celestial or heavenly bodies, as they were called, our planets, our moons, that sort of thing. He also made observations that were more precise than anybody else had previously done. Now, I'm not going into a lot of detail about these guys because you guys are going to do a project here in just a bit to help you learn about these guys a little bit more. Johannes Kepler, he's another guy that's very important. He came up with our laws of planetary motion. And there are 3 things that he said. Number 1, a planet's orbit is elliptical. So it's not really a perfect circle. It's more like an oval or an egg shape. He also stated that the planets revolve at varying speeds. So each planet revolves or goes around its axis at its own speed. Earth could be moving faster than Mars. Okay, Mars could be moving faster than Jupiter, so on and so forth. He also established a relationship between a planet's orbital period and the distance it is to the sun. So how long it takes for it to make one complete circle around the sun, and how close or how far away it is from the sun. So terms that you need to know: ellipse, that's the oval-shaped path. And we also have astronomical units, or what we call AU. And that's the average distance between Earth and the sun, which is roughly about 150 million kilometers. Or if we want to put that into meters, it's about 150,000 meters. No, 150 billion meters. I'm sorry. So planet revolution, the closer you are to the sun, the faster you're going to move. The farther away you are from the sun, the slower you're going to move. So think about figure skaters. Has anybody ever seen figure skating? If you have, when they hold their arms all the way out at their, stretched out as far as it can go at their arm span, they're moving pretty slowly. But if they pull their arms in toward them and suck them, hold them close to their body, they start spinning faster and faster and faster. So another guy that's important is Galileo Galilei. He came up with descriptions of how objects move, so their behavior, and he actually made his own telescope. So he came up with some very important discoveries, such as, number 1, Jupiter has 4 satellites, or what we call moons now. He also came up with the fact that planets are circular disks. They're not just a point of light, so they are spheres. He says that Venus has phases just like the moon. Okay, so if you look at the image down here, you can see Venus, as it changes phases, will actually become a waning crescent, much like our moon does. He also came up with the moon's surface is not smooth, so it has those craters. Okay. And the 5th thing, he came up with the sun has sunspots or very dark regions. And you can see that in both images here. Some other things that you need to know is that our solar system model is evolving. So we started with the Ptolemaic system, which stated that Venus is between the sun and the earth. But it states not only is Venus between the sun and the earth, but it states that Venus moves in a circle between the sun and the earth. And that's not quite true. The Copernican system states that Venus is orbiting the sun and all of the phases are visible from Earth, which we again know is not correct. And then Galileo, of course, observed Venus and he observed those phases. Another important gentleman that you need to know is Sir Isaac Newton. He was the very first to formulate and test the law of universal gravitation. And that's talking about how 2 bodies a certain distance apart have a force acting on them. So the closer 2 things are, the greater the force affecting them. The farther apart, the smaller the force. So the greater also with mass, the bigger the mass, the bigger the force. Okay? So keep that in mind. So how does that affect our orbit? Okay, it affects it because that gravitational force is pulling us toward the sun. But we also have a tendency as a planet, because we're moving in a circle or an ellipse in an oval shape, if there wasn't gravity pulling us down, its regular motion would be to move straight out in one line. And you'll learn more about this in physical science if you choose to take physical science, or if you choose to take physics, you'll learn a lot about this as well. So a couple of terms, barycenter is very similar with mass. So you have objects that are formed around the same time, and you can see how they're formed around one center. But if they're formed at different times, it affects it differently. So if you have 2 bodies that have the same mass, they orbit one barycenter if they're formed at the exact same time. But if they have a similar mass, but they are formed different times, then they're going to orbit on their own in that ellipse. So what would that tell you about all of our planets in comparison to the sun? They were all formed at different times. So different masses if we have a barycenter. So if you have two bodies that have a difference in mass and they orbit one barycenter, then they're going to move kind of almost together but opposite of each other. So these are at a 180-degree angle from each other. Okay, kind of the same thing here. They're still at a 180-degree angle, but this is a major difference in the mass. Okay, one is much larger than the other. This is kind of like Earth and the moon. And then if you have two bodies that are extremely different in their mass, and then they are going to move, the outer one's going to move much more quickly than the inner one. So this is kind of the Sun-Earth model. All right, another important term, nutation. It's a rocking or a swaying, a nodding motion, anything that's on the axis of that object, so how it moves around the axis. So what you see here, it kind of looks like a top spinning once it's losing its momentum. This is kind of what the Earth is doing. Not quite to this extent now, mind you, but this is what's happening to the Earth. We're going through that rocking or swaying motion. Precession is also a term that you need to know. It's the change in the orientation of the rotational axis. So that means it's not only changing from right here, but it's changing and moving this direction too as it spins on its top. Okay, so not only is it spinning this way, but it's also moving round in a broad way. So summer for northern hemisphere, we have more sun up top. Winter in the northern hemisphere, we have more sun on the bottom. Winter in the southern, there's more sun up top, less sun on the bottom. So when we have summer, the southern hemisphere has winter, and we've gone over that several times this semester. All right, so here's what I want you to do for today. There is not really an assignment that goes with this, so this is just the video and the notes. So I want you to go ahead and I'll come around and we'll count off 1 to 12. And then you guys are actually going to start a project and create a brochure looking at all of the different people we've talked about today. So this is where we're going to start, but go ahead and be ready in your group.